Hi everyone, thank you for joining us for today's expert webinar titled Understanding Ingress Application Traffic with Kubernetes. I'm Elizabeth from Spring People. We are India's largest enterprise training provider, and I'll be the moderator for today's session. In today's session, we have Mr. Pradeep, who comes with more than 18 years of extensive experience fault-tolerant, and highly scalable cloud-native applications. He strives on writing clean code, emphasis on domain-driven design principles, and conduct workshops on building production-grade web applications covering all the challenging concerns. Kubernetes is the de facto container orchestration used for deploying container-based applications. One of the challenges that Kubernetes solves is the challenge of service discovery. In this webinar, we will walk through the options of exposing the container service using the Kubernetes services. This webinar will cover how to deploy a microservices-based containers, service discovery, and exposing the service to the end customers. Now, I would like to invite Kubernetes Guru, Pradeep, to start the session. Over to you, Mr. Pradeep.
Yeah, thanks, Elizabeth. Good evening, everyone. My name is Pradeep, and I will be walking you through the topic for today, which is going to be understanding Ingress application traffic with Kubernetes. We will be going through how are we going to deploy a container-based application into Kubernetes cluster, and we're also going to see how we can expose the Kubernetes cluster through our Ingress. All right. So without further ado, I think we can get started with this session. All right. So if you are coming into containers world, so earlier, if you have to go at least 5-6 years before, there was an era where we were working with a traditional IT. How are we deploying our applications earlier? So we were doing that using something called as a traditional VM. So what do you mean by traditional IT or virtual machine based? So typically in a deployment, so what we have is we have the bare metal, we call it as a bare metal server. And on top of the bare metal, we are going to have the host operating system, right? So the host operating system can be your Linux operating system, whether it is Ubuntu, Red Hat, CentOS, right? Any of these host operating system. And on top of that, we are going to install a virtualization software, whether it is from VMware or whether it's an OpenStack, any of this hypervisor is going to be installed on the host operating system. And then on the virtualization, so the operations team install the guest operating systems, right? So these are the VMs on which we will be deploying our applications. So one of the challenges that this kind of architecture has is that there is a gap or there is a bridge between your developers and the operations. So for developers, the source of truth is what we commit into the repository, right? So we might have tested our application on a certain framework, certain platform, probably Java 8 or Java 11 with some specific version. We might have tested this against Tomcat 8 or Tomcat 9, some specific version, right? But what we give as an artifact to our DevOps engineers would be usually only the code and the configuration, right? Now, this also makes sure that the DevOps team must be knowing how to deploy an application, right? They need to know the specifics, the nuances of how do you deploy a Spring Boot application? How do you deploy a Python application? How do you deploy a Nginx application? So they need to be aware of something that the developers are more comfortable with, right? So this actually creates a friction between the developers and operations, because for developers the source of truth is something different, and from the operations the source of truth is something different, right? So if there is any challenge, if there is any vulnerability, or if there is any outage because of this configuration issues, so there would be a friction between the developers and operations team, right? The other thing is that the operations team will have to take the guest operating system, would have to install the platform, whether it is GRE whether it is Node.js, right? And on top of that, they would be deploying your application. And on top of the application, they would be deploying your configuration, right? So they would be building the entire stack, and this is referred to as a traditional IT, or this is also referred to as a monolithic. So this is works fine. This kind of application deployment works fine when you are having a small number of clusters or small number of application servers that you need to manage. But clearly, in the context of microservices, right, where you are going to have multiple instances, very small footprint of applications, this kind of deployment strategy might not be very feasible, right? And that is the reason for containers, which became mainstream, and adoption of containers became very common in today's context. So for deploying your application based on the containers, so we are going to work with something called as a container-based deployment, right? Container-based deployment. So what do we do in case of a container-based deployment? So here the difference is a bit, the way that you deploy is a bit different here. So what do we do in case of container-based deployment, right? So we are going to have the same stack here also. So we are going to have a server, which is going to be your bare metal. And on top of the bare metal, you are going to have your host operating system, right? Again, as we discussed, so it can be any host operating system, and this can be your worker roles, right? So to give you an analogy, in case of your AWS, this can be your EC2 instances, right? You are going to configure your EC2 instances based on some virtualization. And instead of having another layer of abstraction of hypervisor, so we are going to directly install a container runtime, right? Whether it is Docker, whether it is Docker engine or RKT or Podman, any of the container orchestration, container engine. And then once you have the container engine, so you no longer have to set up all the infrastructure that you used to build earlier. All you need to do now is basically you need to get your Docker images, and the Docker images can be used to create containers. So you can think of Docker images as a template, right, as a launch configuration. So which is going to have everything inbuilt, right? It is a self-sufficient image. So the Docker image is going to have your operating system. It is also going to have the platform. It will be having the code. It will be having the configuration. So all of them packaged in a read-only layer, right, is handed over to the operations team. So this traditionally, this on the other hand that we discussed earlier, is much more easier for deployment, because all the nuances of the programming, all the nuances of the application deployment is taken care in the Docker itself, Docker image, and the image has to be just converted into containers, right? From a DevOps perspective, this is much more easier, because all the DevOps team has to know is how do we run your Docker containers, right? How do we manage your Docker containers? So they are liberated from the nuances of application programming. So whether it is a Java image or whether it is a .NET, whether it is built on Tomcat, whether it is built on top of Node.js, right? Whether it is a Ruby application, whether it is a MongoDB. So for us, for the DevOps engineer, it just matters that it is a Docker image. And once they have the Docker image, they will be able to run the containers. They will be able to run the containers, right? So this is the other side of the coin. So now the source of truth becomes between the developers and the operations is no more the artifact, but the source of truth between the developers and operations becomes your Docker image, right? This automatically increases the confidence in terms of the developer team, that if a given Docker image is tested, right, and it is approved by the quality team, so we can be rest assured that it will be running the same way in our production environment, right? This reduces a lot of guessing, right, of lot of uncertainties, and also it increases the confidence for developers to deploy their applications, right? Now, these Docker containers are the miniature version, right? They are self-contained containers. The footprint of these images are very, very less. So one of the drawbacks in case of your traditional IT is that these guest operating systems are very bulky in nature, because they have so many commands, they have so many programs apart from the kernel, right? because of which they are you need constant patching, constant security updates, maintenance of this particular servers. Whereas in case of Docker, so these are the bare minimum kernel, right? And hence the footprint, the memory footprint of these images are very, very small. So hence you will be able to reuse this, means you will be able to create multiple containers, have better resource utilization, and will be able to have smaller footprint, and will be able to run many number of containers in very, very small time. The boot up time of these containers are typically in seconds. Within few seconds your containers will be up and running, which helps us to deploy microservices based deployment. Correct. So this actually becomes the platform on which you are going to deploy your containers. All right. So now that the context is set, now let's understand. So what is the definition of a Docker image? Right? What is the definition of a Docker image? Basically, a definition of Docker image contains your kernel, that is your base operating system, and then you are going to have multiple layers of your application. Each of this layer will be having a layer, and each of these layers are read-only layers. So all of these are basically read-only images. And what you get as an image is a read-only layer, which is a collection of all your layers. Now these are read-only, and all these layers have their references to their parent images, right? The typical size of a image would be in a few MBs, right? Few MBs. Now from the image, what are we going to do? So the Docker platform, the Docker runtime, will be able to understand this Docker image, right? And then it will be able to create containers, right? Create containers and run on the platform. The underlying host OS is immaterial for us, because as long as our Docker images are running over our Docker engine, so we are abstracted away from the host operating system. All right. Now coming back to this particular image, so once we build our Docker image, we are going to share that image, right? So just like when we create our artifacts, we are going to upload that artifact into some repository, whether it is Maven repository, whether it is a Nexus repository, right? So just like that. So when we build our Docker image, so the Docker image will be hosted onto a repository. It can be our Docker registry itself, that is hub.docker.com. So it can be any other container registry, JFrog Artifactory, Sonatype Nexus repository. You can also host it on some private registries like your Elastic Container Registry, ECR, in case of your AWS. Now the steps to build your images are using by writing in instructions using your Docker file. So you're going to write all your instructions in your Docker file, and from the Docker file you are going to run the command to upload the image to your Docker registry. So let me quickly show you what are the components of our Docker file. So this is a simple Spring Boot application that we have, and inside the Spring Boot application, so we have created a Docker file. Now this Docker file has a set of instructions. It starts with a base image, and we have all the instructions in a step-by-step manner. And these commands are basically from Docker. So these commands are basically Docker commands, which will tell the step-by-step instructions on how do we go ahead and build a Docker image. Right? So when we give this file to Docker, the Docker will be able to run this command, and the Docker will be able to run the command. But we need more. So all about microservices is about reducing the manual intervention. And to build the Docker image, we can leverage some CI/CD pipeline. And one of the pipeline that we can use is with respect to our GitLab pipeline. So if I show you the GitLab CI/CD pipeline, so once we have our application, so if I go to my registry, if I go to my application, and you can see here that I have written a CI/CD script, right? So you see this is a pipeline as a service, which pushes these images to which builds that image upon every commit and pushes the image to our Docker registry. So if you go to my Docker registry, you can see that our applications are pushed into our Docker registry as our image. So this is our Docker image, which is hosted under our account. You can see that multiple images are pushed, multiple versions of the images are pushed, and it is easy for us to track down a specific version of the image because this corresponds to our commit ID. So for example, if there is a bug in this particular image, we can easily track down to what are all the changes that went into building this particular image because it is tied up directly to our commit ID. Okay, so this completes one half of the story. So from the developer's perspective, once they commit the changes into the repository, the CI/CD pipeline will commit the changes, build the Docker image, and the Docker image will be pushed into a Docker Hub registry. Now that from this registry, you can pull the Docker images and you can deploy these containers on your Docker platform. But managing these Docker containers is a tedious task, right? You need to know how to run your Docker commands, how to run your containers, how to scale your containers, how to inject the configuration, how do you scale the configuration, how do you do the networking, how do you communicate, inter-pod communication, inter-service communication. So for that reason, so we are going to use something called as Kubernetes. And what is the use of Kubernetes? Kubernetes helps us is a platform. Kubernetes is a platform which will help us to run these containers for us. Right. So if I have to show you the configuration, so this is a typical configuration of our Kubernetes, where we are going to see all the components of a deployment that should be used for our Kubernetes containers. Okay. So Kubernetes acts like an orchestration engine, which is going to do the deployment, service discovery, externalizing the configuration, injecting the sensitive information, right? A service discovery, a service, how to expose a service, how to inject the configuration, right? How to perform the resiliency by exposing liveness and readiness probe, how to perform deployment, how to communicate with the external world. All of those things are provided from Kubernetes. Kubernetes acts as an orchestration engine which helps us to run our Docker containers. So, just to give a context with respect to Kubernetes, just give me 10 minutes. So in Kubernetes, the bare minimum thing is called as a pod in Kubernetes. The basic atomic unit in a Kubernetes is called as a pod. The pod will run the containers. The pod is something that will be present on the node, and the pod is something that will contain multiple containers. So these are the containers, and the pod is built using a container, and there can be multiple containers within the pod, but they will be sharing the same volume. Now, working with a pod is nothing but you are going to run few commands. The definition of pods are written using a YAML file. The definition of pods are written using a YAML file syntax. And to run the pods, so we are going to use something called as a replica set. Okay. And these pods are basically created inside a namespace. A namespace is a logical name inside which you are going to put your resources. And you can share multiple namespaces within the same Kubernetes cluster. Okay. Okay, so now the problem comes in, how are you going to manage your pods? So earlier we were working on how to manage our containers, but how are we going to manage our pods? To manage the pods, so we are going to go with something called as a replica set, and which replica set actually does only one thing. The replica set tells what is the desired number of pod and what is the actual number of pods that we want, right? And how do they communicate with that? They use that label, the concept of label, through which they will be able to decide how many pods should be running at any given point in time. Okay. So we're going to have something called labels. And what does the label do? Without the labels, the pods are all just hanging around, right? They are all arbitrary, running in the resources. So when we attach a label to the pod, so we will be able to categorize them. So you will be able to like these pods belong to your development namespace. This pod belongs to your QA namespace. This pod belongs to your production namespace. This is the environment. This is the version. This is the front end. This is the back end. So you'll be able to segregate, which will help us to categorize the pods, group the pods, and we will be able to perform the operations. Okay. So once we have the pod, then the next thing that we want to do is how are you going to do the deployment, right? So all the container orchestration things can be done using Kubernetes. And once you are done with orchestration, we want to go with the deployment. So in case of Kubernetes, so deployment is a in case of Kubernetes, deployment can be done either via the replica set that we just discussed, or you can go with a blue-green deployment, or we can also go with a canary deployment. So in Kubernetes, there is two different strategies depending on the type of deployment you are planning to go, right? So the majorly you can be categorized the deployment into two parts, that is the recreate or rolling update. So what do you mean by recreate? So in case of recreate, all the existing parts are deleted and the new set of parts are brought back. The older version of the parts are all deleted and the newer version of parts are brought in. So when would you use this kind of use cases? When would you use? So you would use this kind of strategy when your application can afford to have downtime. So your stakeholders, your business requirements can afford to have downtime. That is when you are going to use a recreate. So when this is also used when you cannot have breaking schema changes. So whether the new version of the one version of your application cannot work with the older version of your application. When two different versions of the same application cannot be run together, that is when you are going to work with the recreate strategy. So the other type of strategy is called as a rolling update. So when are you going for a rolling update? When your application does not have when your application you cannot have any instance of downtime, right? And that is the reason when you're going for rolling update. So you can also go with a rolling update when you cannot right. Rolling update is when you can start and delete the pods once the new pods are serving the traffic, right? So you'll have two different versions of the application which are running in parallel, and at any given point of time you will be migrating from one version of application to another application, right? That is when you are going to have your rolling update, where you are not going to have any downtime. So initially version of your application will be v1, and till the time the deployment happens, so the application will go gradually from one version of first version to the second version. So what are deployment in Kubernetes? Kubernetes in the deployment is a resource, just like we have pods, just like we have replica sets, just like you have namespaces. In case of Kubernetes, the deployment is a resource, right? And what does it do? The resource, Kubernetes deployment resource, manages the replica sets, right? And it actually creates the replica set, it actually manages the replica set, and it actually does the migration from one version of the replica set to another version of the replica set. What the deployment resource also does is basically it coordinates the versions between your older version of the replica set and the newer version of the replica set. So during the deployment, you don't have to change anything with respect to service or ingress level. So the existing users will be able to access the resources and there won't be any impact to the users. So by default, the rolling update is the default strategy. How does it work? It removes one pod at a time. And once the new pod is there, it is going to delete the older pod. So first it will bring up a new pod. And once the new pod starts accepting the traffic, it will go back and delete one by one pod. So application is available throughout the deployment, and you use this when application supports both versions of the application to run parallelly. Okay. And the recreate is the strategy when you are going to delete all the pods and replace with the new pods, right? So it is like a big bang deployment. So you are going to delete all the versions, have a downtime, and then you are going to start with a newer version of your application. When would you use this? You would use this when two different versions of the applications cannot run parallelly, and this also causes application downtime during deployment, right? Yes. Okay. So we would be seeing a simple demo, guys. So we will be working in the demo. I'll be showing you what are the different commands that we can go through, what are all the different deployments, and how you can effectively deploy these resources and access these resources from our external service. Okay. Discussed that we would be working with the cluster by using this manifest file. So these are called manifest file. These manifest files are written using your YAML syntax, right? So we'll go through the YAML and then I'll be discussing this. So the first syntax that I'm going to show you is with respect to these are the different resources. The first resource that we are going to discuss is with respect to our secret. And what are these secrets? These are the secrets that you are going to inject into your application pod. Any sensitive information like your username, passwords, right? Any sensitive information that you want to inject to the container, you are going to write via the secret. And once you are done with the secret, next we are going to look at how do you deploy your configurations? How you are going to inject your configurations, right? You want to externalize your configuration and put the configuration to your pods. So here I have application-dev.yaml where I'm going to have all our configuration, right? This is application configuration. And I'm also having my application-prod configuration. So basically it is a key and a value pair. The key is the name of the file and the value is the content of the file. Okay. So we are going to have two configurations and then you are going to supply them as part of your configuration map. Similarly, you can see here that I have used the DB credentials to encode the DB credentials as a secret. So that means we are not going to hard code the DB credentials inside of configuration. At the same time, the configurations, the sensitive information are kept in a secret rather than being used in a version control system. We are not going to commit this into a version control system. The next resource that I want to discuss is with respect to the deployment itself. The deployment will have a YAML file which tells the type of the deployment, that is the name of the deployment, how many parts that we want to use. I'm going to tell that we want to have 2 parts, and we are going to tell that what is the name of the container that we want, what are the image name. The image name is nothing but this is a Docker image that we have pushed to our Docker registry. And we are also going to supply our configurations, like what is the environment that we want to run, right? The moment I tell spring.profiles.active is equal to tell, our YAML file with respect to your application dev will be picked up. So if you want to pick up our QA configuration, so then I'll be giving it QA. Then I'll also be giving you the database username, the database password, whatever we created there. And then using this configuration, we will be able to push that configuration, right? Push the configuration to our containers. The application will be hosted, the Docker image is hosted in registry, right? We just discussed that. So this is a Docker image. And you can see that the Docker images is hosted to a private registry. That means what? Nobody will be able to pull that image directly. And you need to have authenticated and authorized to be able to pull that image. And for that reason, I'm going to use a Docker pull secrets. So which is going to ensure that we will be able to pull that image safely from our Docker registry, right? It is a safer way of uploading your Docker images, right? The other thing that we are going to use is we are going to tell that this is our service, and we can also see here, we can also do pretty much other things. We are also telling that what is the volume mount. We are telling that inject the configuration. We are also telling the resiliency here, that liveness probe and the readiness probe, ensuring that if the pod is for some reason is not working, restart the pod. And you're also telling that if the pod is not ready to serve any traffic, don't send that traffic to this particular pod. And lastly, we are going to come to the service. So once we have the deployment, so we want to expose this as a service. So service is another resource which we are going to use, and which is going to tell that anytime when you hit a traffic on port number 80, we will be redirecting the traffic to port number 8222, right? So the type of service is going to be cluster IP. That means what? The definition of these pods will be available only in your private. So you will not be able to access this particular service outside of your Kubernetes cluster. So that is what is the meaning of this service. So to give you context on how it works, so this is how it works. So you're going to have your pods. These will be your pods, and these pods are basically backed by a replica set, and these replica sets are exposed via a service, and these are present typically in a private subnet. So if you're coming from AWS background, or if you're deploying that into cloud, so this will be deployed onto your private subnets on your worker nodes. Then you're going to see this. This is going to be a cluster IP. So here we have your pods, and then you're going to have your server-side load balancing done by your service-side vendors. Okay. So typically, this would be your Kubernetes architecture, where you would have this Kubernetes architecture where you would be deploying that into two different planes. One of them is called as a control plane, the other is called as a data plane. And then you would also have your clients that will be connecting to your cluster. Okay. So the control plane will be containing your API server, etcd, scheduler, and controllers, whereas your worker nodes is where we are going to deploy your Kubernetes pods. Okay. So let's with this we should be good to start with our hands-on. So currently I am in my terminal, and what I will be doing is I will be showing you some of the commands that will be useful for us to deploy our changes. Okay? So let me go to this particular thing. Let me go to the Revealing Explorer. So start with the terminal. Here we have our manifest. So first thing that I'm going to do is I'm going to create a namespace where we will be deploying our resources. So first I'll be running the kubectl create namespace, right? And the next thing that I will be doing is I'll be switching to this particular namespace. Okay. So once we're done with that, we can see currently that there are no pods. There are no pods. There are no replica set. There is no deployment. There is no configuration maps. There is no secrets. Right? You can see that. And there is no service. So none of these are there. Now what I will be doing is I will be uploading this particular file, the YAML file, by running this command. Kubectl apply SNS status auto microphones. And the moment we are doing this, you can see here the secret gets created. DB credentials, all of this gets created. Okay. Now if you select kubectl get deployment, you can see that there are two pods that are running. And if you run kubectl get replica set, you can see that there are two replicas. And if it will get pods, there are two pods. There are two pods which are running, right? And then if you see, you have already kubectl get services are there, right? And there is also an ingress, and we also have the configuration maps, and then we have secrets. So all of these resources are created just by executing one specific command. All of these resources got created. Correct? Now we can check the status of the deployment by running the kubectl rollout status deployment order Python microservice. So this is going to be one of your microservice. So typically you can have multiple of these microservices running together, and all of them, right, these microservices will be able to communicate within each other, right? With each other, they will be able to communicate via the service. But as you see, all of these are resolved via the cluster IP address. That is what no traffic will be allowed from your outside the cluster to the inside the cluster. So for that reason, to allow any traffic from your outside the cluster, from public IP address, from your browsers, right? So for that reason, we are going to use another resource called Ingress. And what is an Ingress? Ingress is basically a resource through which you will be able to exercise the traffic from your external resource. The Ingress is going to send the resource, and the Ingress internally will send the traffic to your services. And from the services, the traffic will go to your pods. So typically, this is the full-fledged production setup for your Ingress, where you are going to have different domain names: dev.classpath.com, qa.classpath.com, stage.classpath.com, and then you are going to have one Ingress controller which will have DNS records with a public IP address. Now, from the Ingress, you are going to route to the different namespaces based on the host name. And for that reason, what I have already done is I have already created an Ingress. So if I tell kubectl get Ingress, you can see here that there is an Ingress called test.classpath.io. And you can see here that this is going to be the public IP address. And where is this public IP address, by the way? So when we deployed our manifest file, you can see here that a load balancer got provisioned behind the scenes. So this is our Kubernetes cluster. And we can see that the load balancer got provisioned within the scenes. So what you can also do is if you go to our cluster, Kubernetes cluster, and you should also be able to go to the cluster, go in the dashboard and see all those resources from the UI. So it is not necessary that you always do via your command prompt. You can also check all these resources about the running status in your Kubernetes cluster. So you can select here the namespace. So the namespace that we have created is basically a webinar namespace. And the webinar namespace, I can see that how many parts are running. There are 2 parts we are running. There is one replica set that is running. There is one deployment that is running, right? And you can see here that there is an Ingress, application Ingress. There is a config maps, secrets. So all of those things are present here. So we should be able to see all the details in our UI. Now, the next thing that we are going to do is we have our load balancer, application load balancer that is created. And this load balancer should be assigned to our Ingress. So currently I do not have my domain name registered. So for that reason, I'm going to go to my notepad. And I'm going to open in an administrator mode. And I'm opening this particular file, the host file, etc host file, right? So why are we adding? Because the domain name is not registered on the DNS record. So I'm going to come here and I'm going to tell this IP address is test.classpath.io, and this is going to be the IP address. So that anytime I'm going to tell test.classpath.io, it will be resolving to the IP address of my load balancer. So now after doing this, so if I come here, if I go here, if I tell that http run test.classpath.io /orders /API /dn /orders, you can see here that we start getting our response from our internet. Is it correct? So this is how we were able to we are going to use our Ingress, right, to deploy our resources and access the application via your device. So let us go to the definition of the YAML and understand how it is working behind the scenes, right? So here what we gave test.class.io is assigned to a specific namespace. Right? You can see here that it is assigned to a namespace, and whenever we are hitting this URL, this ingress will automatically route to the test.class.io. And the next is basically our orders, right? The orders, and these orders will take this URL. And what it does is anytime anything that follows that will be sent as it is, and then we are going to forward that particular traffic to our order service. What is an order service? This order service is the same service that we have created earlier, right? So this is a service that we have created, this service. And to this service, we are going to send the traffic. And this service definition is here itself, order service. See here. So we are redirecting the port number 80 of the service. And what the order service does is it basically takes this service and it is going to redirect that our application to port number 8222. So 8222 is a port to which our application is running on, port number 8222. And our application will be injected with the configuration maps, and then our application will be able to serve the traffic. So we will try to do the same thing from our command prompt. So we are going to tell curl http test dot last path dot slash orders slash orders, and you can see that we are able to get the response. And what I can also do is I can get the pods, kubectl get ingress, and what I can do is I can describe the ingress. You can also refer, you can also see that ingress application icon, and you can see that this particular ingress has a route called test.class.io, and it is forwarding to order microservice, order service. Now, if we track down this order service, kubectl get svc, we will be able to see that there is a cluster IP and it is not having any external IP. And if I do a describe order service, we can see here that it is backed by two different pods. And if I tell kubectl get pod, I do see here that there are the two pods. Now what I can do is I can log into one of the pod and I can run kubectl logs and this, and I can see how our application being running. Our application is running, correct? So now what I can do is I can go into the pod, I can click into the pod. So we are able to see inside the pod, and if I do curl http localhost 8222 slash guys and you can see that we are getting a response. Not only this, we can also refer it to by the cluster IP, because the cluster IP is resolved from within your cluster. It is not available outside the cluster. So basically, this is how you will be able to use all these patterns to build a cloud native container based application. So what is the advantage? Now, if you're coming from days where you are deploying this application using your traditional monolithic architecture, or you're using something like Spring Cloud, right? Spring Cloud Eureka server, Spring Cloud config server, Spring Cloud Eureka Histric, right? Config server, Zool API gateway. So this is going to be very useful for the reason that your applications are obviously going to become lightweight. So if you see here, none of my application dependency, I do not have anything to do with Spring Cloud. I do not have Eureka server. I do not have Eureka client. I do not have the dependency of configuration server. But at the same time, So we are able to get our application to only address our business logic, and all the infrastructure things are taken care by our Kubernetes. So, and Kubernetes and Spring Boot also works very well with each other for the reason that you can also have, since when working with Spring Boot, we work with something called actuators, which will help us to expose production metrics related data. So we can also expose metrics related to circuit breaker, right? And we can also expose our health endpoints. So I'll give you one small demo, guys. So currently I have one REST controller, and what does that do is it automatically updates the liveness state of our application. And based on this, Kubernetes can use this information to restart the pod or not send the traffic. So basically what it means is you have your application which is exposing whether it is healthy or not, and this information is interpreted by Kubernetes and decides whether to restart the container or basically to stop sending the traffic, right? So I'll just give you a small demo on this. So basically we go here into the pod. So currently I'm going to make it to fail. So by running this particular URL, -x host, and I'm going to tell localhost 8222 /API /state /liveness. So I'm going to break this liveness code, and you can see that the application is down now. And once it is down, you can see that the pod will automatically get restarted and automatically. So this is also a good thing in Kubernetes, which is helpful for us to build something called as a self-healing application. Self-healing application in a sense, if it is not able to connect to the server, or you want it to restart for it to clear its cache and bring back. So this is one of the very nice things where Kubernetes will automatically call the liveness probe, and it will automatically schedule the pod to start again. So here, because I made that pod to fail, so the Kubernetes was intelligent enough to restart the pod, and after some time, the pod will be created. Right? So Kubernetes also is very, very resilient in the sense that if I try to delete all the pods, it understands that it needs to create a certain set of pods, and automatically it is going to come. See, two parts are, and how soon it came. So it just took 2-3 seconds to spin up a new part. Is that correct, guys? So basically, with the Spring Boot application, with deployment, with Ingress, you should be able to build production grade cloud native applications which are built for scaling. Is that okay? Okay, so with that being said, so this is how you are going to work with your Kubernetes. So Kubernetes deployment. So you can also do some deployments like blue-green deployment. So where you are going to tell your application, current version of your application is there in production, and then you are going to send all the traffic to your application, and a new version of your application being deployed, and then you are going to cut over that from your existing application to the new application. This is called blue-green deployment. You can also go with the canary deployment, where you are going to tell that 10% of the traffic should go from your, for 80% of the traffic should go from your older one, and the 10% of the traffic should go to your new version. So all of those things can also be done using your, is that clear? Okay. All right. So Elizabeth, would you like to start?
Yes, sir. Thank you, Pradeep, for a wonderful session. I'm sure it was certainly a very informative session for all of you. If you guys are interested in learning more about Kubernetes, do check out our super discounted trainings that we offer at Spring People. And these trainings are leveraged online from the comforts of your home and flexible as per your schedule and location. If you do not find any suitable batches, we would be happy to discuss and schedule private batches for you. For more information, do write us at training@springpeople.com or call on our number displayed on the current slide. Now, we will open the forum for Pradeep to answer the questions that we received during the session. So, let's get our questions answered. Over to you, Pradeep.
Okay, thank you. So there are a few questions which are very, very interesting. So I will take this time to answer a few questions. The first question we have is there a way to distribute the traffic, right? Like blue-green deployment, blue-green where 80% of the traffic should go to the new and rest of the 20% go to the previous version? Yes. So this is typically called as a canary deployment, not the blue-green deployment. In the blue-green deployment, what you do is you will have the traffic which will be going to your existing. So, and then you will come up with a new environment, and then you will cut off that to your old one from the new one. So you will be able to do that also. How do you do that? By resuming the deployment by pausing the deployment in the middle, so you will be able to do that also. That is taken care. And the question is where did you take the Docker credentials to pull that image? So as we discussed, we are using the secrets, right? So secrets come in different flavors. Secrets can be used for service accounts. Secret can be for opaque tokens. And one of the type of secret is called Docker secret, Docker configuration. So you would be creating a secret using your Docker configuration and injecting into the pod using something called as image pull secrets, using which your application, your Docker, your Kubernetes will be able, your pod will be able to pull that image from your private registry. Right. The other question is, what is a service account and RBAC? So basically, in case of your Kubernetes, especially when you're working with something called as an EKS, right? Elastic Kubernetes Service in AWS platform. Kubernetes within the Kubernetes ecosystem, Kubernetes does not understand the IAM roles, right? IAM roles, IAM users, IAM groups, right? So for setting the authentication and authorization, right? That let's say the developer should be able to only access this particular result. They should not be able to delete any cluster, right? Create a cluster. Operations should be able to create a cluster, right? So you are going to provide a role-based access control in order for you. So for that reason, you are going to use RBAC. And service account is basically a account which you are going to inject into a pod, and you are going to add a role to a service account through which you will be able to get elevated permissions to perform any operations like connecting to a S3 bucket or fetching the secret from a secrets manager, right? Or setting up a cluster autoscaler. So for all of those things, you would set up a service accounts, and we'll be assigning the roles to the service accounts. Okay, so in the Ingress manifest file, I could see a Ingress class name. Yes, so you would actually set up Ingress, and you would be setting up your Ingress class name. I did not see the remaining question. Okay, so there are a few other questions. Does Kubernetes provide CI/CD pipeline integrated with Kubernetes? No, Kubernetes does not have the concept of CI/CD pipeline. So you can set up the CI/CD pipeline using GitHub, GitLab, Jenkins, right? Or for continuous integration, and for continuous deployment also, you can go for some CI/CD pipelines like Jenkins X, Flux, AgroCD, so where you will be able to deploy your changes to your version control system, and your pipeline will be able to perform continuous deployment also. So like GKE in GCP is a similar one in AWS. I did not get back to your question. Okay. Okay, any other questions we have? So one of the advantages of using with Kubernetes is basically it lets you abstract away from the infrastructure dependencies, right? So where you would be able to deploy your manifest file across on-prem applications, cloud platforms like AWS, GKE, and Azure, right? Okay, so there is one more question with respect to how to secure Ingress host. So for securing Ingress host, you are going to use some certificate, right? So you can use the certificate from companies like Let's Encrypt, or you can use a certificate from AWS Certificate Manager, and you can set up a certificate on your Ingress, right? So that means, and you'll also set up a rewrite rule that any traffic that comes to your port number 80, you will not reject or you will not throttle, but in case you will be able to redirect that to port number 443, and then you will be able to do that. Right? The other thing that you can also do, guys, is that you will be able to set up a DNS name or your Route 53 in your AWS, and you will be able to point that DNS name to your Ingress controller. Correct? So in the Ingress controller, there are different types of Ingress controller. So you can go with the Kong API gateway controller, you can go with Asana, you can go with FPG, you can go with Nginx Ingress controller, or you can also go with AWS API gateway Ingress controller. So those are the options that are available for you to implement the Ingress controllers, right? So any reference link for Ingress controller and load balancer? Yes, we will be sharing that. We'll be sharing that also, right, as part of this. All right. Any other questions we have? So what is the difference between a config map and secrets? Yes. So basically configuration maps are basically to externalize the configuration from your application. So instead of hard coding the configuration within your application, what happens is if you want to update any configuration, it would be very difficult, right? So how will you update the configuration for tens and 15s of pods that you have in your cluster, right? So you would typically externalize the configuration of your application configuration and inject the configuration. So there are different ways in which you can inject the config maps. You can inject the configuration using a files. So basically you can create a config maps. You can integrate that with AWS parameter store, right? So to pull the configuration from parameter store, you can also inject the configuration maps as your environmental variables, right? Or you can also inject the config maps by reading it from the configuration file. Right? All those things can be done using your config maps. And the difference between config maps and secret are primarily used for sensitive information, whereas configuration maps are not used for sensitive information. The sensitive information are encoded in base64 format. That is the difference between configuration map and secrets. All right. What kind of application configuration we put in the config map? Let's say you're working with a Spring Boot application. So your application configurations will write. So application-dev.yaml, application-qa.yaml, application-prod.yaml. What is your environmental variable? What is your server ports, right? And let's say what is your DB host name, DB URL, right? What is your Kafka broker address? All of those things can be supplied as part of your configuration files. And sensitive information like your DB credentials, Kafka credentials, right? Broker credentials. So those are the information that you are going to set up using your secrets. All right, nice. That was very interesting, very engaging, good questions. So thanks for your questions. All your questions will be answered. Please feel free to send out the questions, right? And we will be more than happy to answer all your questions, right? So with that being said, I would like to hand over this again to Elizabeth, who will be concluding this session.
Thank you, Pradeep, for answering all questions. And thank you, everyone, for joining this webinar. We shall be sending out the webinar recording to all participants soon. And I request you to kindly provide feedback before signing off, which will help us to improve the quality of our future events. And once again, thank you for joining us today. Signing off on behalf of Team Spring People. Hope to see you again for our next webinar. Bye all.